The global food system is currently losing approximately one-third of all food produced before it reaches a human mouth, and fruit and vegetable processing waste, including peels, seeds, stems, and pulp, represents one of the largest single categories within that loss. This is simultaneously an environmental crisis, an economic inefficiency, and a nutritional paradox. The parts of food plants being discarded at the highest volumes are, as the evidence reviewed across this entire body of research consistently demonstrates, among the most nutritionally concentrated components of the foods being processed. A food system that treats its most bioactive fractions as waste is not merely inefficient. It is structurally irrational, and the case for reorganizing it around a circular nutrition model is now both scientifically and economically compelling. The circular food economy concept, applied specifically to peel valorization, is not a utopian vision requiring technological breakthroughs that do not yet exist. The technological components are available, and several are already deployed at partial scale. Ultrasound-assisted extraction and supercritical carbon dioxide extraction methods can recover heat-sensitive polyphenol, essential oils, and carotenoids from peel fractions at industrial scale while preserving the bioactive properties that make them nutritionally and commercially valuable. These are not laboratory curiosities. They are operating technologies in pharmaceutical and food ingredient production that have not yet been systematically applied to the full range of fruit and vegetable processing byproducts. The commercial incentive structure is also shifting in ways that make peel valorization economically viable in a manner it was not a decade ago. Consumer demand for clean-label, plant-derived functional ingredients has created premium market segments for natural antioxidants, plant-based prebiotic fibers, and botanical antimicrobials, exactly the compound classes concentrated in fruit and vegetable peels. The same material that costs a food processor money to dispose of as waste is the raw material for ingredients that command significant market value in the functional food and nutraceutical sectors. That economic inversion is already driving commercial interest in peel valorization at the industry level, but it remains fragmented and suboptimal because comprehensive research mapping peel bioactive profiles across the full spectrum of processing byproducts has not been systematically compiled. The environmental arithmetic reinforces the economic case. Life cycle assessments of peel valorization consistently show substantially lower environmental footprint per unit of functional ingredient produced compared to dedicated cultivation and processing of crops for the same purpose. Extracting quercetin from apple processing waste uses significantly less land, water, and energy than growing apple-specific crops for quercetin production. The sustainability argument for circular peel valorization is not a secondary consideration. In the context of regulatory momentum around food waste reduction targets being adopted across the European Union and increasingly in other jurisdictions, it is becoming a primary commercial driver. The honest conclusion this entire body of research supports is that the most nutritionally dense parts of the foods the world produces are being systematically discarded because the food system has never been organized around capturing their value. The science to characterize that value, the technology to extract it, the markets to absorb it, and the environmental rationale to prioritize it are all present simultaneously for the first time. What remains is the institutional decision to treat peel nutrition as a core food system priority rather than a marginal research interest, and the consequences of making or failing to make that decision will be measured in nutritional outcomes, environmental costs, and economic value for decades to come.